Welcome, today we are talking about how to design a 0.5 kVA solar-based inverter system. This is a final year project is designed by Ifan Yichwu Opera, a student of Covenant University Ada. From the Department of Electrical Engineering. This is a joint collaboration between myself and Smartech to design a 0.5 kVA solar-based inverter. I will be demonstrating the working efficiency and how to design this 0.5 kVA solar-powered inverter project. This project design is a pure sine wave solar-based inverter that uses a 100 watts panel to recharge a 12 volts battery through a PWM charge controller as shown here. With the system turned off to avoid arcing, I connect the battery terminals, first the positive terminal. Next is the connection of the negative wire onto the inverter 12 volts DC battery terminal. The alligator clip for the 12 volts battery is connected to the battery positive lead. The same is done for the negative terminal of the 12 volts battery lead. The inverter is powered on by flipping the power button by the side of the casing. The charge controller would display that the battery is connected. The battery voltage too is displayed on the screen. The battery level is at 12.1 volts and the PV panel isn't connected as indicated. To use the inverted voltage, which is the AC output, this switch here is turned on. This is the AC output connected to a 100 watts tungsten light bulb, and it is powering it successfully. We can see the inverted output AC voltage on the multimeter as well as the DC battery voltage on the charge controller. Now, let us dive in proper, how to design this 0.5 kVA solar inverter system. See circuit diagram in the description link below. After the circuit diagram was made, it is converted to a PCB full and then printed out. The result is what we have here. If you want a copy of this PCB, kindly send us a message. Care must be taken to ensure that heavy soldering is placed on the MOSFET voltage switching sides. With this PCB, we can start assembling the components together. Assembling the inverter components together. Assembly of the components started like this. We placed all the needed components on the PCB and soldered them. These relays here are used to switch between inverted AC voltage output and AC mains output. When the heat sinks are connected, we can quickly run a test to see if things are going in the right direction. All connections are terminated accordingly and the miniature 12 volts DC battery is used for this test. Please wear an insulative gloves if you are new at this. This video demonstration shows an expert who can do without insulation gloves. Connecting the control part of the inverter circuit to the battery. We can see that the AC light bulb comes on. The amplitude of the voltage is also quite high, hence the light intensity of the AC light bulb is bright. This means that we can use a multimeter to check the generated inverter AC voltage of the inverter from the 12 volts DC battery. The voltmeter reads the AC voltage of the inverter output when it is turned on. We can see it go from 0 volts to 235 volts AC. Next is to encase the DAC in a plastic case. It should be able to fit in nicely and have an opening where the charge controller can be connected to. The type of transformer used for this design and all its specifications are detailed in the blog link below. Ensure you read the blog to understand this video better. The AC voltage generated is 231.2 volts at a DC voltage of 11.3 volts. We can also charge a mobile phone via the USB port designated for USB phone charging. Calibration of the inverter and running diagnostic tests. The inverter output voltage can be calibrated to ensure that the inverted AC voltage doesn't exceed a particular amplitude. Calibration is also important because it helps ensure the output voltage is a sine wave AC voltage. Testing the project design. Testing the project design. The project design has been completed in its construction, and when powered on, it can power AC appliances like light bulbs and other AC actuators. And that is a wrap, everyone. See you on the next one. Thank you.